You either replace this by sine over cosine and you get that, or you condense this and you get this. So in this particular case, it doesn't really matter. You want to start with the right-hand side this time? Let's start with the right-hand side. So I have natural log of a quantity minus natural log of a different quantity. This is natural log of the absolute value of this over this. From the properties of logs. But this will be replaced by tangent. And this is it. So this is the left-hand side. Done. Any questions? Okay, let's see if we want to look at anything else. So we can look at 102 and 8892. You choose. If not, we'll move on. We will have other trig identities to establish later on. Anyone would like to choose 88, 92, 102, or move on? '88, 92, or 102, or we move on.
We do 92.
Yes, let's work on 92. There's a lot of writing with these. I'm sorry. 11. So 92, we said 1 plus cosine theta plus sine theta. Everything divided by 1 plus cosine theta but minus sine theta. Okay. They say it equals secant theta plus tangent theta. Okay. Good. So let's take a look and see what we do here. Which side do you consider as our starting point? Left or right?
Left.
Very good. I would do the same thing. Okay. So I agree with this. However, let's see if I copied it correctly. Just making sure. It was 1 plus cosine plus sine, 1 plus cosine minus sine, secant, and tangent. Okay. With this one, I really have no idea what to do. So my thinking is I cannot separate, I cannot simplify. There is nothing I can do here. And I'm thinking to act on one. Because remember, a minute ago, we said sine squared plus cosine squared is 1. But I also can replace 1 by sine squared plus cosine squared. I don't know if that's going to help in any way, shape, or form. I'm just going to try. Don't write it down just yet. So sine squared theta plus cosine squared theta plus cosine theta plus sine theta. And the denominator, again, sine squared theta plus cosine squared theta plus cosine theta minus sine theta. Let's see if I get myself into more trouble or I'm getting somewhere. Okay. If I factor between these two, I get the sine plus 1. If I factor between these two, I get cosine plus 1. Sine plus 1, cosine plus 1. I'm not getting anywhere that way. If I change this into 1 minus cosine squared, 1 minus cosine squared, I'm just going around in circles. One plus cosine. There are other options in which we multiply top and bottom by a certain quantity. I don't see it at this point. Let's see the minus sine squared, cosine squared. If I start here, I have 1 over cosine and sine over cosine. I have 1 plus sine, 1 plus cosine. I'm not getting anywhere either way. So let's think some more. Can I sine squared plus cosine squared? One plus cosine plus sine. Because we cannot simplify, we cannot separate the terms into different fractions. Okay. So the left-hand side, I have to start one more. I don't see any simplifications here by replacing 1 by sine squared plus cosine squared. I'm looking again. Sine with sine, cosine with cosine. So here I'll have cosine plus 1, and here I have cosine plus 1. And it's not going to help. Okay. I don't see that it's helping. Okay, 1 plus cosine squared plus sine over 1 plus cosine theta minus sine theta. This is a simple situation here. It's 1 plus sine theta over cosine theta. So this is the simplified form of this. I just wanted to see it for a second. So see if that gives me an idea how to get from here over there. Again, don't write anything yet. I'm not sure where I'm going with this. Sine theta. So if I multiply top and bottom by 1 plus sine theta, what do I get? I get 1 plus sine theta squared when I distribute this to these two, plus cosine 1 plus sine theta. When I multiply here, I get cosine squared theta plus cosine theta. I'll explain in a minute what I'm doing. I'm multiplying this by this, and I get cosine squared, and this by this. So when I multiply k and cosine, okay. And cosine squared. Okay. If I do that and I factor out, what did I accomplish? Did I accomplish anything? Cosine theta. And I have 1, no, I have cosine theta plus 1 plus sine theta. Okay. I didn't accomplish much, but let's see what I get at the top. If I factor 1 plus sine theta, I get 1 plus sine theta plus cosine theta. Okay. Yep. So we got the right-hand side. But now I have to explain what I did. So I'm going to start again to explain to you what I just did. That was an interesting one. Which page am I on? 12. Okay. So I'm going to start from scratch. And we had the left-hand side, which is kind of weird. You have to admit, plus sine theta over 1 plus cosine theta minus sine theta. I cannot simplify even if I change as I did initially. If I change 1 into sine squared plus cosine squared, nothing worked. I could not factor or simplify. So this, I'm going to cross it out so it doesn't confuse you. It's a path that I got stuck on immediately. Now, how did I come up with the idea of multiplying top and bottom by 1 plus sine theta? In a way from here. Because secant is 1 over cosine, and this is sine over cosine. So the simplified form of secant plus tangent is 1 plus sine over cosine. 1 plus sine over cosine. So I said, okay, let me see if I multiply top and bottom by 1 plus sine theta. Let's see what happens. And I can multiply because when I multiply by sine, 1 plus sine over 1 plus sine, I'm multiplying by 1. So 1 plus sine theta, 1 plus sine theta. So this doesn't change the original problem because this is 1 in the form of 1 plus sine over 1 plus sine. And then 1 plus sine times 1. 1 plus sine times cosine. 1 plus sine times sine. So I multiplied it instead of distributing, because it would have been a little bit more difficult to notice what I'm trying to do. I multiplied it in the following way. I have a 1 plus sine. 1 plus sine times 1 plus sine is 1 plus sine theta squared. So I distributed this to these two terms, and I have 1 plus sine squared. Now I have to distribute this to cosine. So plus cosine theta, parentheses, 1 plus sine theta. One more time. It's not a good idea to say 1 times 1, 1 times cosine, 1 times sine, sine times 1, sine times this, sine times this, because I will have, 6 terms, and I will not know what to do with them. I will have to come back and try to factor. So I distributed 1 plus sine to 1 plus sine, and I got 1 plus sine squared, and then I distributed 1 plus sine to cosine, so I got this. I will do the same thing with the denominator. I distribute 1 plus sine to 1 minus sine squared, but we just looked at that. 1 minus sine times 1 plus sine is 1 minus sine squared, which is cosine squared. So cosine squared theta. 1 minus sine times 1 plus sine is 1 minus sine squared, which you already told me several times tonight is cosine squared. But I have to distribute 1 plus sine to cosine. So plus cosine, parentheses, 1 plus sine theta. Okay, at this point, in the denominator, I can only factor out cosine theta. Cosine theta, and I have in brackets cosine theta. This is out, plus 1 plus sine. Let's see what we have in the numerator. The two terms in the numerator have a common factor of 1 plus sine. So 1 plus sine theta. What is left from here? 1 plus sine theta. What is left from here? Cosine theta. That's all I wanted. I wanted to get rid of this complicated situation that I didn't know what to do with. So 1 plus sine plus cosine, 1 plus sine plus cosine, same quantity, it goes away. So the final simplified form is 1 plus sine theta over cosine theta, which indeed is the right-hand side. Without this little trick, I would have not known how to get to the right-hand side. And this was something that we started with, multiplying and dividing by the same quantity. So in this case, I didn't need this. I really needed the 1 plus sine. This was an interesting one. Anything else? Or can we move on? I'd like to start. I know I have only 10 minutes left, roughly. But I'd like to start the next section. But of course, let me know. So this was this. This was the most involving one tonight. Now, this is an easy one, or easier, because the denominator is one term. Cosine over sine is cotangent. Sine over sine is 1. Minus sine squared over sine will be sine squared. And you will get the cosine squared. This is straightforward, one line. But this one required a little trick. And the last one, it's a product, right? So natural log of a quantity plus a natural log of another quantity, it's natural log of the product. And when you multiply these, I'm assuming you will get 1, probably, yes. So, yes, secant squared plus tangent squared, minus tangent squared, which is 1. And natural log is 0. So the only one that required a little trick was this one. Okay, I'd like to at least start the next one. Any questions for me? Any questions? Okay, so this section 6.5 deals with sum and difference formulas. Okay. Of course, more identities. So hold on to your seats. There is a lot more. Okay. So 6.5, sum plus difference. What does this mean? Well, let me see where my video is. Oh, I still have time. Okay. So in other words, we're talking about adding two angles and then applying sine to it, or difference. Cosine. Sum and difference formulas. Sine of a sum or sine of a difference. A cosine of a sum and cosine of a difference. Tangent of a sum or a difference. These are the identities called sum or difference identities. And formulas are very different for all these. So let's start with sine. Maybe it's better if I just write a plus b or minus b. Maybe it's easier for you to remember, maybe, maybe not. Okay, so here's the formula. Sine A cosine B, so I'm going to put this in one color, plus the reverse. Sine B times cosine A. If it's minus, of course there is minus here. So this is how you should remember them. Sine A cosine B plus sine B cosine A, if it's positive. If it's a difference, sine A cosine B minus sine B cosine A. Cosine is totally different. Cosine A plus B is cosine A cosine B, but minus. So if this is positive, this is minus. Got two minuses. You remember I like to write so you know if something follows. Sine A, sine B. If there is minus here, then there is plus here. So the signs for cosines are opposite. Sine A plus B is sine A cosine B plus sine B cosine A. But cosine A plus B is cosine A cosine B minus sine A sine B. And the last one for tangent, that is a fraction. Tangent A plus or minus B is tangent A plus tangent B over 1 minus tangent A tangent B. So if this is minus, but this is plus. So plus has plus at the top, but minus in the denominator. The minus has minus at the top and plus at the denominator. What are we going to do with this? So let me